in this situation, we're actually pulling the material that we learned from our last unit in first semester and in this first unit this semester. So it's a proportion problem. We have Ricky's Hot Dogs. It's a restaurant. They noticed that 2 of the last 14 customers that came through their shop wanted to have a veggie dog. So they want to know, out of the next 21 customers that come in, how many of them should they expect to order a veggie dog? So they're trying to make a prediction, and this is actually something very common in a lot of different businesses. If I'm a restaurant owner, go ahead. If I'm a restaurant owner and I notice that, okay, I've got French fries for a side and I've got broccoli for a side. And I notice that people don't really order broccoli as much as they do French fries. Do you think that I'm going to order the same amount of French fries as I do broccoli? No. When I'm trying to stock my restaurant up, I'm not going to stock up a whole bunch of broccoli and equal amounts of the French fries if I know French fries are the most popular dish. Okay? Because what happens? At the end of the day, I've got all this broccoli. What's going to happen to all that broccoli? It's going to go bad, right? I'm going to eventually have to throw it out. And if I have to throw away stuff that I've purchased because I can't use it anymore, I lose money. So this is actually a common trend or a common concept that business owners have to do every single day. They have to take stock of what gets sold the most at their business or at their restaurant, and what do they need to make sure that they purchase the most of, and maybe what do they need to relax on. So they're using experimental probability. What do they notice? What data did they collect on it to make a prediction for how much do they need to purchase for the future? Okay, so the same thing here. We're using an experimental probability, what actually has happened. So far, what actually has happened is that we've had 2 customers out of 14 that have ordered the veggie dog. So 2 customers out of the 14 customers that just recently came in ordered that veggie dog. So this is the probability of ordering a veggie dog. I'm finding the probability. Remember, we write probability as P and then the event that we're looking for. So currently, the probability of a veggie dog being ordered is 2 over 14. 2 veggie dogs have been purchased out of 14 customers that have come in. What we're going to do is we're going to use that probability to create a prediction. So I want to set this equal to a prediction. So I'm going to write predict veggie. So what I want to know is how many are going to be veggie dogs out of 21 customers. It says it right here. How many of the next 21 customers are going to order the veggie dog? So once we have this set up, it's now a proportion. You guys have been solving proportions for the past 2 months. Okay, you did it all throughout the end of November, all the way through December. You did all of January. We have been doing nothing but proportions for a little over 2 months. Okay, we are going to multiply. So we're going to multiply 2 times the 21. And then we're going to multiply 14 times the x. So we get 14x is equal to 42. You got to wait. Okay, 14x is equal to 42. What do we do now? Nick? Divide both sides by 14. Okay, so when we divide both sides by 14, we're going to get that x is equal to 3. Are they all done? Yeah. Anybody have a spare calculator inside their desks? Yeah. Thank you, EJ. Oh, or thank you, Eileen. You're good. Okay, so that means that we have x. We can expect 3 people to order a veggie dog out of the next 21 customers. Is that guaranteed to happen? If I have 21 more people coming through, am I guaranteed that there's only going to be 3 veggie dogs sold? No. It's just a prediction. Remember, predictions are the same thing as estimates. We're estimating that 3 veggie dogs would be sold. Okay, but all you're doing is you're finding out your probability first, then setting it equal to X over a newer total, okay, to make a prediction. Same thing here. So this was experimental probability because this was actions. 2 people came in out of 14 people and ordered something. That was an action. Here, for problem 2, no action has happened yet. I'm saying, hey, I'm going to pull a marble 20 times, and I want to identify, well, how many of those 20 pulls should be green. So before I do that, I need to know what the probability of green is. So this is theoretical probability. Before anything has actually even happened yet, what's the probability of green? So who can tell me what the probability of pulling a green marble would be? What out of what? 3 out of 5, right? There are 3 green marbles, right? 1, 2, 3 out of 5 total marbles. So the probability that I'm going to pull a green marble is 3 out of 5. Now I want to predict. I want to predict green out of 20 pulls, right? 20 times I want to go ahead and pull a marble out. I want to predict how often should I expect to pull out a green. Okay, so again, we're going to multiply 5 times x and 3 times 20. That's going to give us 5x is equal to 60 because 3 times 20 is equal to 60. What's our last step from here? Divide both sides by 5. Okay, and we'll get that. We can expect 12 green. Okay, doesn't necessarily mean it's going to happen that way. Remember, it's a prediction. So the key word would be about. About 12 times we can expect a green. Maybe it might be a little more, maybe it might be a little bit less. Okay? So this is what you're going to be doing today on your IXLs. You're going to be doing an IXL using theoretical probability to make a prediction and using experimental probability to make prediction, and then also one IXL on just experimental probability. Go ahead and get into Google Classroom and begin.